Okay, welcome to episode 4. In this episode, we are going to look at how to control the brightness of an LED. If you remember, in episode 3, we learned how to turn an LED on or off. Just two things: how to turn an LED on or off using just a simple push button. We also learned how to use the breadboard. We went through the basics of using the breadboard and all that. So this is a build-up. I also mentioned in the previous episode that what we did was more like a digital signal, and what we are going to do today is more like playing with analog signals. And I promise that I'm going to explain those two words, analog and then digital. So let's just use some simple words to describe what an analog signal is and then what a digital signal is too. So when we talk about a digital signal in electronics, we are talking about any signal that can only exist in two forms or in two states alone. How do we call it? On and off, high or low, left or right, how do you call it, bright or dark. Maybe you can also think about some words, any property in this world that can only exist in two forms. I'm tempted to say male and female, and also what else, up or down. The list goes on. So any form of signal, any form of property that can only express itself in two forms can be classified as a digital signal. So the reason why I said what we did in the previous episode was a digital signal is because the push button was controlling the LED in just two possible forms. It's either the LED was going to be on or the LED was going to be off. That is it. We can keep it there for now. Now, when we also talk about analog signals, we are also talking about properties or signals that can exist over some sort of a range, so over a wide range. So let's just use the, how do we call it, the things in your own house as an example. For example, the lights in your room and then the fan in your room. You realize that when it comes to the lights, you are only turning it on or off in most houses. You are just turning the light on or you are turning the light off. It ends there. But when it comes to your ceiling fan or even your standing fan, you are not only telling the fan to come on or off, you are actually controlling the speed of the fan. So you can see some sort of a calibration on the controller of your fan. You can see 0, you can see 1, you can see 2, 3, 4, and then 5. So that is some sort of a representation of an analog signal. Unlike your lights where you just turn it 1 or 0, on or off, the analog signal exists over a range. And a typical one is your fan, as I just said. You would have to turn it from 0, 1, 2, 3, depending on how fast you want your fan to move. Yeah, exactly. And as I mentioned about digital signals, you realize that computers only understand digital signals, or the basics of computation today are digital signals. So if you've heard about binaries before, binaries means just 0 and then 1. I hope you get it right. Wonderful. Okay, so with that said, in this particular video, we are also going to try and build a circuit that mimics some sort of analog signal control, because as I said in the previous video, we did something digital, turn on the LED on and off. So in this particular video, we are going to use an electronic component called a potentiometer to control the brightness of an LED. So this time we are not only telling the LED to come on or off, but we are going to control how bright or how dim the LED is. after these two, episode 3, episode 4, you perfectly now should understand what it means to control a digital signal and what it means to control an analog signal manually. Because mind you, we haven't started programming yet, so we are not using any form of code to tell the Arduino, to tell the electronics component what to do. We are actually trying to manually implement digital signal control and then analog signal control. I want you to take it easy because you have to get these concepts very well in order to have mastery over the very things we'll be doing in the upcoming episodes. Stick around. Okay, so let's go into it already. If you have your Arduino Starter Kit, you should have a potentiometer inside of it already. This is the potentiometer. I hope you can see it. Yes. In fact, let me bring it up here on the screen so that it will be easier to demonstrate. I actually want to show you how the potentiometer works firstly, even before we attempt to use it to build anything. So if you take a look at the potentiometer, it has 3 pins. 1, 2, 3. Yeah. Though there are labelings on each of these pins from this software, it's not really compulsory how they've labeled it, just that this is like the way you find it most of the time. So the first one says ground, the second one is output, and then the third one VCC. I showed us in the previous episodes that ground is like the lowest voltage, which is 0, and then VCC is the highest voltage in your circuit, or the voltage you are working with, the primary voltage you are working with. Since we are going to be using Arduino down the line, Arduino works or operates with 5 volts, so our VCC is always going to be 5 volts, and then our ground is going to be 0 volts in a certain sense. So just imagine this: if you are to supply 0 volts here, or if you connect this to the ground and then you connect this to Arduino's 5 volts, what is going to happen is there's going to be a signal coming out of the output pin at any point in time, and this signal is going to be forever between the values of 0 and then 5. Imagine instead of 5 volts you connected a 12 volt power supply rather to this potentiometer. You would connect 0 volts of the power supply here and then 12 volts here. It means that as I turn this knob, the signal I'm going to be reading out of this particular or the output pin is going to fall within the 0 and then the 12. So the potentiometer works in such a way that it tries to share or it tries to partition the voltage at the boundaries, the voltage at the left and at the right. The voltage that you find here, the voltage that you find here is going to be partitioned, and then the output is going to come out of this middle pin. Yes. So I will just try and then do some form of a very simple circuit with it, just to demonstrate how it works. Let's still use the Arduino Uno as a power supply for the meantime. Arduino Uno. Yeah, this is it. Okay. So then again, we are all aware that there's 5 volt power supply on the Arduino board. So let me just grab 5 volts from the Arduino board and connect it to VCC. Okay, so I have my power from the Arduino board connected to my breadboard now, and what I want to do is to power this potentiometer with this same voltage. So all I can do is all I have to do is just to take my power from here. I can take my ground directly from here. I hope you get it this way. There's ground here. I've connected it to this lower part of the circuit, and then it is in turn connected to the ground of the potentiometer. So the next thing I must do is to connect the VCC also to the same power line, which has already come from the Arduino, 5 volts, right? Good. So I've just powered the potentiometer with 5 volts and ground. That's all. So this means that if I should hold the knob of the potentiometer and if I should turn it left and right, I'm actually just sharing or balancing the voltage that's going to come out of the middle. If I turn the knob anti-clockwise, all the way anti-clockwise, if I turn the knob all the way anti-clockwise, I am going to be reading 0 volt at the middle pin. But if I should turn it all the way clockwise, it means that I'm going to read 5 volts at the middle pin. If I'm very good and I'm able to balance the potentiometer somewhere in the middle, then it means that I'm expecting 2.5 volt, which is half of 5 volts. Exactly that. So that is the job the potentiometer literally does. So let's just bring an LED into the scene. So I can see this red LED here. Let me put it somewhere on the breadboard. Again, mind you, the LED has it's a polarized component, which is it has a designated positive and a designated negative. I showed us how to find that in the previous episode. Kindly refer to it if you have no idea what I'm talking about right now. So instead of taking 5 volts from the power supply directly, I'm just going to take it from the outputs of the potentiometer instead. From the output of the potentiometer instead. So this is it. Okay. All I have to do now is to connect the other end of the LED, which is the is it the cathode? Yes, I have to connect that one all the way to ground, connecting the negative terminal of the LED to ground. Yeah, I've already connected the anode or the positive part of the LED to the signal. So it's really that simple. That is it. You are done. Yeah. Unfortunately, I don't think this software can simulate like a potentiometer reading. I'm not sure. So we'll just do that inside the real environment. Yeah. Okay. It doesn't support it. I thought as much. So yeah, what is happening here is there is 5 volt supply coming from the breadboard, coming from the Arduino. So this is what is happening. We are only using the Arduino board as a power supply. We are only using it as a power supply, and 5 volts from the Arduino has been connected to the top rails of the breadboard. And also, we've used the same 5 volts to power the both ends of the potentiometer. Connected the ground to the left and then the VCC to the right. And because of how I've done it currently, if I should turn the potentiometer all the way to the right, the middle pin is going to bring out the full 5 volt voltage to the LED. If I did it the other way around, that is, if I sent the VCC to the left and then the ground rather to the right, the logic would have been the other way around. Good. So just imagine that the fan in your house, if I should come and open it and I should change the circuitry, your grandmother will come to the house, and then instead of seeing the fan speed increase when she turns it clockwise, it will rather be decreasing. Like the logic has been inverted. So you just have to be, depending on whatever you're using the potentiometer to control, you just have to be very logical about how you position your VCC and then your ground. Yeah. Okay, so we are just going to try and replicate what we did on the screen just here. So this is the real world. I repeat, this is the real world. So just be careful how you make your connections as well. Okay, I have my potentiometer in place and then my Arduino board here too. So since we are just using the Arduino board as a power supply, I need two simple jumper wires to take 5 volts from my Arduino board and introduce it to the positive part of my breadboard, and then also ground from the Arduino board to the ground of the breadboard as well. Yeah, I'm doing it this way because I'm aware there are people who are so new to electronics, so I'm just taking my time to do this. If you're already familiar with this, just push the video ahead or forward the video to the end. Yeah. So once I now have power from my breadboard, from my Arduino board on my breadboard, now I can now take the same power, which is 5 volts from my breadboard, to the right end, the right pin of the potentiometer, and then I take power from the ground as well. I take a signal from the ground to the left terminal of the potentiometer. It's exactly what we did on the screen, so I'm just repeating it. Now that I have done this, I can now have access to a signal at the middle terminal of the potentiometer. So the signal coming out of the middle part of the potentiometer is what we will eventually send to the LED. This particular signal from the middle part of the potentiometer is going to the LED. So I can insert it somewhere here, and then let me find an LED. Okay, so I have a red LED here. I'm going to connect the positive part of this red LED to where I placed the signal, and now the only thing that is left for me to do is to ground the LED, is to take a cable from here to the ground of the breadboard or the Arduino again. Yeah. But if you remember from the first video, I made mention that these LEDs usually support 3 volts. So imagine that when I power the whole system up, maybe it's at 0 volts. But if I should turn it all the way to the right, 5 volts will now be present at where the LED is. And because 5 volts is more than the LED, it may damage the LED, or it will damage the LED for sure. And it will be advisable to put a resistor right after the LED or before the LED, that is in between the circuits of the LED, before you ground your circuit. But curiosity says I should ignore the resistor for now, so that you all can see how this works. Yeah. So now that the circuit is done, all I have to do is to use the Arduino's USB cable to power up the Arduino itself. Okay, so the USB parts of the this part of the USB goes to any USB that has power. You could connect it to your computer, or I have a power bank here, a very simple power bank here. I can also connect it to my power bank instead. All right, let me keep it somewhere here. Okay, so my Arduino is powered up and it is also powering my system, just that currently the potentiometer has been turned all the way anti-clockwise, which is 0 volt. If I shall start turning it clockwise, you see the LED lighten up slowly. Let me see what happens when I take it all the way to 5 volts. Okay, it's bright. Without my resistor, I'm not seeing any trouble here, but it's only a matter of time as the LED is exposed to 5 volts for a long period. It may just tolerate you for a bit. So best practice, you need to put a resistor somewhere between the lines. So let me just grab a very small resistor. Okay, this is 220 ohm. So in between the LED and then the ground, I just placed a resistor somewhere there. So now we are safe. We can go all the way to the left, all the way to the right. So this kind of gives you an idea about how analog signals also work. So instead of sending either 0 volt or 5 volts to the LED, we are now sending streams of values in between 0 and 5 volts to the LED. In the world of the digital signals, you could only send either 0 volt or 5 volt, that is on or off, to the LED. But because of the potentiometer, you can now sort of balance the voltage between 0 and then 5 volts, and then take the result to the LED. That is a representation of an analog signal. Yeah. Then again, the load we used today is an LED. So sending analog signals to an LED is obviously going to influence the brightness of the LED. But what if it was a DC motor? Yes, a DC motor would react to analog signals by speed variations. So lower voltages sent to a DC motor will make the DC motor move slower, and then higher voltages will also make it move faster. That is exactly what is happening here. Yeah. Okay. So it only gets more interesting from here, because in the next episode, which is episode 5, we are going to start programming. We're going to start using the Arduino board more intensively here. Instead of all the things we did using like manual methods or analog methods, we are actually going to now start programming on the computer and uploading our programs to the Arduino. So the Arduino is going to take care of all the logical input and output operations. So stick around as we delve much more deeper into microcontroller electronics, programming, and robotics in general. See you in the next episode. By the way, don't forget to like this video and subscribe, and also share with a friend who you think will be interested in this particular series. See you in the next episode. Bye bye.